Okay, hi, hello everyone. This is your Vignesh from your Mr. Vignesh Tutorials. Welcome to my YouTube channel. So here comes our next lecture. That is, I think it's lecture 4 from the unit 2 of physics. So physics lecture 4 unit 2, that is force, work, energy and power. So we completed force, we completed work. Now we'll discuss what is energy. Actually, it is a small topic only. On a brief, to tell what is energy. Energy is a physical quantity which is a different form for the work done. That is, see, when the work is being done, there is some energy produced or some energy absorbed. Like energy in the sense here, we are talking about some, let's say in physical form it is calories, like we are walking or running for some time, okay, or like we are doing some physical exercise, let's say we are dancing or we are doing some anything work, so some calories in our body are getting burnt, right? So the calorie produce some energy. So and some energy is not in the form of only that form, physical form, it may be any mechanical form, chemical energy, mechanical energy, electrical energy. We have different kinds of energy. Now fan, it's a mechanical energy, cell, it's a chemical energy, and let's say some electronic gadgets, they have some electrical energy. So different forms of energy. And heat energy, let's say if we rub our hands, for example, we get heat to our arms, our hands become warm. This is due to heat energy, because the mechanical energy is converted into heat energy. So there are a lot of process of conversion of energies. And one more thing I want to tell is, energy is synthesis of work done, I can tell. It is nothing but when work is being processed or after the processing of work, the synthesis of that work is nothing but energy. The unit of energy is joules. And there are different forms of energy. They are, just now we discussed, heat energy, chemical energy and mechanical energy, thermal energy or heat energy, both are same, okay, heat energy or thermal energy, both are same. And we have electrical energy, some bioenergy, like examples, like we have a lot of things. We have heat energy, chemical energy, electrical energy, mechanical energy, bioenergy and many other forms of energy. I can give you some examples like heat energy, all the things related to temperature or sun or anything or climate, whatever the temperature, those are forms of some heat energy. The temperature is rising, that means heat is rising. Where is that heat being produced? It is a form of energy. Light is also a form of energy. Now energy, light energy is also a source. It's an electromagnetic spectrum, right? In the spectrum you are getting some light, which is a form of energy. Now chemical energy, like cells, batteries. Now light is also, like it's produced artificially from cells and batteries, that is comes under chemical energy only. Electrical or anything energy, like from circuits, some inductors or capacitors, like these kind of things, resistors. We have electrical energy, they store electrical energy, like coil, it produces some current around it. Now charge carrying capacitor, it shows the charge. So these are some electrical energy. And like in electrical energy in general, in our household purpose also, we get some electrical bill, no? We have this much power, you have used this much of energy, they say in watts or in kilowatts, like per hour or per second, something like that. So there is also form of energy. And physical energy, you have bioenergy also. Bioenergy means energy produced from some food, like yeast is producing some energy, like a human being is producing some energy in doing some work. So these are some kinds of examples of different kinds of energy in different various forms. This is all due to synthesis of the work done. So the basic definition is synthesis of work done is called as energy, and these are the examples of energy. See, you may feel my way of explanation bit faster or bit in a flow. Thing is, you have to catch in a fast manner so that you can cope up with the concept as well as the problems in a speed. When there is a speed, your brain will improve, your brain will become sharp. You can crack any exam at an ease. Within no time you can clear each and every problem, you can go on the way. Okay, so that is what I meant to be. So I'll be explaining very slowly also, that when you have doubts, if you have doubts, keep those doubts or mention them in the comment box. I will come up with a slow and detailed explanation of that particular topic in the upcoming videos. Okay, as of now, this is the explanation it's going to be. So these are the different forms of work, synthesis of work and energy. So you can take screenshot of it. I'll tell what is like, I'll tell some problem on energy and then we'll move on to the power concept. Okay, take a screenshot of it. Okay, I hope you have done this. Okay, now thing is, I'm going to discuss some examples on energy. Examples, energy. Let's say in our household. So okay, before going to example of this on energy, I'll tell you what is power, and at a stretch I can tell you that example in a detailed manner with the help of energy and power respected to our household thing. Okay, in our household we use voltage and we use current. V is symbol for voltage, I is symbol for current. From transformers or some liners we get to our household. Okay, in our household, let's say it's a house, we have different rooms. Let's say some 3 rooms, some bedroom, hall, kitchen. Let's say 1 BHK. Okay, so let's say that power is going. Power will all like voltage or power will always be transmitted in parallel connections in our rooms, because this is a general gate type of question, some MCQ type of question. It will be always connected in parallel manner. Why not series? If it is connected in series, if we are switching off one light or one fan, the whole circuit is going to switch off. There is no connection. There is no there is a gap. The connectivity is lost. So you are connecting in the parallel. Every switch and everything you are connecting in the parallel, so that when you are offing or when it is damaged also, our circuit is not going to, our system or household circuit is not going to get affected. So we are connecting in the parallel, and the voltage which we are using will be 220 to 240 volt generally, coming from the transformer. It's a very high voltage thing. If you catch, literally you will get burst up within no time, because the speed of the electrons is, you already know, that great speed flows into your body, your bloods, everything, cells gets exhausted. And like there's some sort of question in the IP, I remember, like a crow is standing on a voltaged wire. The wire is in on condition, current is being flown. Crow came and standing on that. These are the legs of the crow, let's say. Okay, this is a beak, let's say this is some feathers. Okay, this is the crow, let's say. Okay, let's say it's a crow standing on that wire. Now, why that crow is not getting shocked? In general, if we are catching any wire or conductor which is flowing electrons in that, we get shock, right? Why this is not flowing? We get only shock when one terminal is catching that and other terminal is at some other potential or other voltage. Now, if we are standing on the ground is neutral, it's a zero potential. Let's say for example, we are catching a high voltage, so electrons will flow from the high voltage to ground, so it will be passed through us and we get shocked. This is what the scenario is going to happen. But here, in this case, the crow, the 2 legs of the crow are catching the same wire. That means both of the legs are at same potential. Between same potential, the current won't flow in the other line. So because there is a flow, let's say it's a battery, let's say it's a resistor. Now there is a wire. Current will flow in this direction, but if there is another loop, current won't flow in this direction because there is no resistance. It won't flow in other direction. Got it? It won't flow like current will come like this and it flows to the body. It's not like that. There should be some difference in the voltages. Then only you will get that shock effect. Otherwise, there won't be any flow of electrons. So sometimes we find this also. Some birds, some crows, basically crows or some other birds, they get died or they get shot due to shock on the electrical wires. Why this happens? Sir, you told nothing happens. Yes, nothing happens, but sometimes due to wind effect or some movement, they may be stuck between two wires. Between two wires, there may be the change in the potential or voltage such that flow of electrons or current takes place from the body of the bird and it gets shocked, then automatically it has to die. Yes, it has to die. Thing is, we have to deal the physics in a systematic manner, in a simplified and educated manner. Most economically we have to deal. So this is the case going to happen. So, okay, apart from this example, let's come back to our topic. So, BHK, we have this voltage, 220 volt, everything. So, thing is, in our household, we get electricity bill, right? In electricity bill, you have some token number, you have some numbers, everything. You get some power consumption. Power consumption. What is meant by power? The amount of work done in unit time or per unit time is called as power. The amount of work done per unit time is called as power. Let's say power, work done by unit time. It's T, or rate of work done also you can tell, or work done per unit time. I hope my writing is clear. That means you have to divide simply work and time. Got it? Where this power is function of work with respect to time. Got it? It is a work only with respect to time. If you are doing, that is a power, and the unit is joules. Even joules per second, and energy we have unit as joules, or sometimes calories also. There is some small conversion change between this joule and calories. We have some specific heat constant value. Okay. Due to that, there will be some change in the value of this unit, joules and calories. In general, we use joules for kgs, meter per second square, some kind of things. Now, this is the power. Its unit will be, the work done is Newton meter, this is second. So, Newton meter per second or joule per second. Newton meter is also called as joule. So, work done unit may be also taken as joule, and energy is also joule. Energy is also form of the work done only. But power is nothing but the rate of work done or work done per unit area is called as power. And in general, in electricity bills, we have some, like you got 60 watts of power, you got 180 watts of power, some kind of different units, same units only but different values. What is that? You are using 60 watts of energy. Here, joule per second is also called as watt, because the scientist Watt has discovered or coined the name power. So we know why the names are like this, means those are some scientists from Greek and Latin or some other concept from French and from some other countries. So they have coined the name. So in honor of them, we have given this name as watts. So what scientist has discovered? Now watt is the other form of joule per second. So you are consuming 60 joule per second in 1 second. 60 joules per 1 second you are consuming. So your power consumed is 60, or like for other house it is 180. So he is consuming 3 times of first house. So this is how it is going to be, and they are going to charge accordingly. Sir, for one unit they measure as like units. 1 unit is equal to, let's say, for example, it has some value actually. 1 unit is equal to, let's say, some power consumed into cost of 1 unit. We'll have some cost of 1 unit, so that we'll get price. We have some sums also. Price equal to 1 unit into number of units into unit price. They'll charge unit price. For example, let's say 3 rupees per unit they are charging on electricity bill. We are producing electricity from coal and some other resources in our Telangana state, especially like in India also mostly from coal only. So they have charges, government has laying charges on us. So we are paying approximately rupees 3 per unit, let's say. So here let's say there is for example a house got 60 units of power consumed. So 60 into 3 equal to 180 rupees they have to pay. This is one formula, and this is one formula price. So this is a unit joule per second or watt. So these are the main things you have to remember. So I hope we are clear till so far. So I don't think we need much more examples on it. If you want, I can make one more video also. Please let me know how far it reached you and what are the doubts you have and what else you are expecting from me to explain from this chapter. So this is all about the unit 2, force, work, energy and power, and if possible I will make one more video with all different kinds of example problems so that it may be helpful for your normal physics or MSET, JEE mains and advanced as well. So take a screenshot of it, it's very important. Okay. So as of now we have done with our session. So it may be our lecture 4 or lecture 5, whatever it is. So I'll be doing one more video also. I'll be coming up as soon as possible. So until then, signing off. This is your Vignesh from your Mr. Vignesh Tutorials. Keep watching my videos. Like, share and comment my videos and subscribe my channel. Don't forget to click on the bell icon. So signing off.